Okay, cool. So we are doing today the problem number, like problem is unique path. So what it says that like we have been given a grid with having some rows and columns. Okay, so let's say you may have 3 columns or 3 rows or 4 columns or 3 rows, whatever is given to you. Okay, and then you need to find the different ways to reach the last cell. So for example, if I talk about, you see, let's say we take three rows and 4 columns. Okay, so from this position you need to reach this last cell, this position. Last cell means this position. Okay,
Okay.
and there can be example, can be like, it can be various ways to reach the cell. Maybe you traverse from first position, go straight and then move downwards, or it can be like go straight till the second, like till the second column, then move down and reach here, or maybe from here, or directly from like go down and then towards right. Okay, so basically these are the things being given to you, that given, okay, it's number of rows and columns, and you need to go from 0 comma 0, you are present initially at 0 comma 0, and you need to move to the right, like you need to move to the last cell. Now apart from this, like, the given things, and like where you need to reach and basically what you need to find, there is one set of other thing is also given to you, that you can either move downwards or you can either move towards the right. Okay, so these are the two choices I can say that is being given to you. You can either move downwards or either move towards right. Is that clear?
Yes.
Okay. So these are the things being discussed. So let's say we follow one approach where we discuss, like as I told you, that there are two choices. Either you can move towards right or you can move towards down. Okay. So the journal equation becomes like, as we do it always, that if you're present at row any particular position such as R comma C, then if you move towards right, then your the indexes of that the row and column would be like R comma C plus 1, because since moving towards right, column index will be incremented. Does that make sense?
Yes.
And if you move down, the row index will be incremented. Is it clear?
Yes.
Okay, so let's think of this with an example and like see how the recursive equation would be. So let's say for an m is equals to 3 and n is equals to 3, we define these steps. Let's say we are present at 0 comma 0. There are two steps we follow, either move towards right or move towards down. When we follow towards right, we increment the column, and if we move down, we increment the row. Now similarly, we solve this for all these subproblems. Let's say we follow for 0 1. 0 1 would be subdivided into 0 comma 2, 1 comma 1. Then 0 comma 2 would be divided into 0 comma 3, 1 comma 2, and hence we'll be like solving this. So on solving all these things, you will be able to identify one of the few cases, like one of the case being that since m is equals to 3 and n is equals to 2, n is equals to 3, so you have 3 rows and 3 columns. Okay, and based on that, if you reach the last index, so you are starting from 0, right? So 0 1 2 3 is something which is getting out of the column which we are like for. Are you understanding this point? Like, since we have 3 rows and 3 columns and we are starting from 0, so the max index for the any column, it would be 2.
0, 2. All right.
Right? So here it comes 3. So it means that it's reached, you can say we have reached out of that index. So we can directly return 0. Does that make sense?
Right.
Right? And similarly, we can we can see for this as well, for 1 comma 3 as well. And then there is another case which we need to see, like once this is one of the case where like we follow, like while solving the recursive equations, we see various base cases. So this is one of the base case, and there is another case when the exact match happens. So this exact match is when basically like when you reach the end index, basically the last index which the user set, right? So you directly return 1 from there, right?
Okay.
So this is what
Right.
this is what we want to find. So these are the two cases, and based on these two cases, we are solving the problem. Now, to solve this like what basically this is one of the recursive equation. Now again, you see on approach to what we do, we see basically what we see is there are some of the sub problems which are being repeated. For example, 1 comma 1 1 comma 1 are being repeated, right?
Right.
Right. So we don't, if it is solved already, we don't want to solve it again. So we definitely take support of hash map, and that's where we combine the solution recursive equation with the hash map. We stored some of the common sub problems in our hash map. Okay, and that makes through our dynamic programming solution. Does that make sense till here?
Yes.
Okay. So if I so the optimization is done definitely in the approach too, which I have not written. So since you are already aware of the things I've already discussed in the previous problems, Hana? So I'll discuss in the code part for that. So on the side of like when we see the time complexity and space complexity, we definitely see the worst cases. So on the time, if we see the worst case, we see we have two choices, right? Either moving right or down. And
Right.
right, for every cell we have two choices, and for there are total number of cells are m into n, like m rows and n columns. You can multiply there are these
Right.
many cells, right? So the time complexity will become, in the worst case, 2 raised to power m into n. Okay,
Right.
and the space complexity, definitely again the worst case will have to see the largest branch. So the largest branch will depend on the number of rows and the columns, which will be the largest. So correspondingly, we can say the max of m into n, whichever is the largest.
Space complexity. Can you explain it once again?
Yeah. So I mean here, let's say there can be situations where then like there can be situation where the number of either the number of rows are higher as compared to number of columns, or the number of columns can be higher than the number of rows. So we need to basically take the max of either the number of rows or the number of columns. For example, if you see that let's say here it is m is
Okay.
equals to 3, n is equals to 3, right? So the max position, it will be 2 comma 2. Let's say it can be, let's say we took one example right here where you see
4,
there are
2.
so here the number of which are highest, there are 3 rows and 4 columns, right? So
Column.
the largest branch would see towards the largest branch would be having which has the maximum columns, right? So it would be this, right?
Right.
So that would
Right.
so that would be the max space complexity we would need to store all these in our stack.
Right.
Okay, does that make sense?
Right. Yes.
Cool. So this is how we're gonna solve the unique paths, and basically to like basically now comes the code part. So I did some I guess currently lead code is not working. Should have so that I can show the code. Otherwise, this is how we're gonna work on unique paths and all. Okay. Uh, that's the cool. Let me stop the recording now.